Okay, to find, somebody wanted to see question A here. Let me see if we can figure out where this is coming from. This is exercise 4.2, question 2A from the new ibid book. Okay, and they want the Maclaurin expansion for ln of 1 plus 1/2 x. Once again, the trick here is to recognize that we have many of these Maclaurin series expansions in the formula booklet. And the formula booklet here says that there's one for 1 ln of 1 plus x. I believe we developed this earlier in class, but now you have it on the formula sheet. It says x minus x squared over 2 plus x to the 3 over 3, and you can see the general form is some sort of alternating thing here, x to the n over n factorial, and it starts positive, so we better put n plus 1. So when n is 1, we get a positive term. Okay, so if you want to do that now for the ln of 1 plus 1/2 x, you just have to think of this as the x, 1/2 x, and substitute 1/2 x every time you see x in the Maclaurin series expansion from the formula sheet. So that gives us 1/2 x here all squared over 2 plus 1/2 x all cubed over 3, and then not sure what the answers look like. In an exam, they would have to let you know if they wanted the general term or not. Just to get the general term, that would be minus 1 to the n plus 1, 1/2 x to the n over n factorial. So if we do a little simplification here, it's x over 2 minus x squared. Well, this will be over 8 because right here, this half gets squared. So it's 1 over 4 divided by 2, which is 1 over 8. Okay, and then the next term would be plus, well, this again here is going to be 1 over 8, and then it's divided by 3, so plus 1 over 24 x cubed, and then the general term is minus 1 to the n plus 1. You got an x to the n up here, and on the bottom it's 2 to the power of n times, I put n factorial, that's a mistake really, just times, it's just divided by n. So we can take that factorial off here, right? So no factorial here, just an n there. Okay, and that's it. If they want it in summation notation, we can do that too. N goes from, starts at 1 though, to infinity, minus 1 to the n plus 1, x to the n, 2 to the n, times n. And having a glance up at the solutions here from ibid, we can confirm that that is correct.